Hello, my name is Lucas Hessler, and welcome to my first lab video for Physics 2212 on charged tapes. Before I jump into the actual experiment, I just want to give a little brief overview of my agenda for this presentation. First, I'm going to start with an experiment introduction and then transition into the fundamental principles that I applied to this experiment. Um, Moving on, we'll go into experiment observations and calculations, and then finally kind of wrap it up with my glow script model that brings these calculations to life, and then finally tie it all together with a conclusion and some reflective questions. So in this experiment, we dealt with the interaction between charged particles, and this helped me learn about the idea of charges and how they affect one another. In order to complete this experiment, I needed to make some estimates and simplify some assumptions in order to actually be able to reach a feasible answer. I was able to kick off this experiment by applying Coulomb's law to find my tape charge of 1.519 times 10 to the negative 8 coulombs. For simplicity, I will discuss the other principles I used before moving on to the actual experiment part. So as you can see here, these are the basic principles that I applied to my experiment. We know Coulomb's law was utilized to find the charge of the tape, and we took the assumption that both Q values, Q1 and Q2 in this equation, are equivalent. In addition to Coulomb's, I used Newton's second law in order to apply the force of gravity into my calculations. And lastly, of course, it's necessary to include analysis for point charges and how their electric fields are affected. This electric field formula encapsulates that. Now diving into the actual experiment. So this experiment essentially just involved two pieces of tape, and we were tasked to learn about how their charges can interact with each other, essentially. So in order to do this, I first established a base tape on the surface. Then I placed an upper tape on top of it and removed it, thus creating the charge. From there, I monitored the interactions and calculated the excess charge left over. The next aspect of this experiment included monitoring the interactions between the tape charge and the charged plastic pen. I learned that if the tape is positively charged, then it's going to attract the negatively charged pen. And on the flip side, if the tape is negatively charged, it will repel the pen. And this visual down here kind of encapsulates how two charged particles, whatever combination they may be, would interact with each other. Before moving on to calculations, I just wanted to clarify some assumptions that I made in order to make my calculations. These included that the tapes act as point charges. Each tape has the same net charge. We assumed and calculated mass in atoms purely based on tape length. And finally, obviously, air resistance would have an effect on our experiment, but for calculations and analysis purposes, I just made air resistance negligible. Moving on to the calculations, first I found the force of gravity in regards to tape, and this was 2.496 newtons. I noted the mass of the tape, which was taken using the length of the tape times the ratio of 1 gram per meter of tape, and that came out to be 0.252 grams, and the separation distance on tape B, which was 0.029 meters. Now, using the force of gravity, I was able to find the charge on tape B by solving for Q, which computed to 4.8303 times 10 to the negative 7 newtons. From there, I was able to find the number of electrons by dividing this Q by the charge of an electron. This came out to be 3.019 times 10 to the 12th electrons. Continuing on with these calculations, I was able to find the total number of atoms by, as I said in my assumptions, using tape length and width. And this came out to be 4.284 times 10 to the 17th atoms. And to wrap it all up, I finally used these last two values to compute the ratio of atoms to electrons, which came out to be 7.047 times 10 to the negative 6. Here we can see my glow script model that I used to bring these calculations to life. We see in this model that the charges are repelling each other in this graphic, but the gravitational force is actually balancing the electrical force as it goes downwards on the y-axis. On the left is the code I used for this. And this is the function I defined to really establish the charge arrows and how they interact in this model. Finally, covering some reflection questions. If electrons and protons has reverse charge, then the strips of tape would actually still have the same charge and still repel. In regards to the second question, it's important to handle the tapes as little as possible due to the fact that charged strips of tape hold excess electrons, and those are easily lost with any interactions we have with them. And that's all I have for my presentation. Thank you so much, and I'm looking forward to the rest of this class and the labs to come.